right, 4.4 polynomial functions. You know what? Start with the first screen. Quick review of factoring. If we're going to deal with factoring polynomial functions, which is what we're doing in this section, we need to remember how to factor just a quadratic. So quick review. So I'm going to factor a quadratic. I like to use just this little method here. I'm going to do multiply a times c, my a term times my c term. Okay, remember this is in the form of ax squared plus bx plus c. I'm assuming that we're all good on the quadratics there. And our first term is 2, so a times c, our last term. 2 times negative 4 gives me negative 8. I want two things to multiply to make negative 8 and add to 7. In this case, those two things would be 8 and negative 1. Okay, 8 times negative 1 makes negative 8, add to 7. So I can write out my quantities. I have x plus 8, x minus 1. And then I'm going to divide by my a term. My a term is 2. So if I divide by 2, divide that by 2 and that by 2, and reduce, I get x plus 4. 8 divided by 2 is 4. And I can't reduce here or do anything with the 1/2, so what I'm going to do is pull that 2 out in front here. So 2x minus 1. So my quick and easy way to deal with factoring. So I factored that now. 2x squared plus 7x minus 4 is equal to x plus 4 times 2x minus 1. Okay, so quick review of factoring there. Now, when we're dealing with polynomials, there are a bunch of things we need to look for. First thing, we always want to try to factor out a monomial first. And notice it says factor completely. That means we keep going until we can't factor anything else out. So monomial just means I'm taking out a greatest common factor. So is there anything that goes into all three of these terms? And in this case, there is an x. X goes into x cubed, or x times what is x cubed? That would be x squared. X times what is negative x squared? Well, that would be negative x. And x times what is negative 6x? That would be negative 6. And now once I'm done there, I've got to look at what I have remaining on the inside of the parentheses and see if I can factor that. Well, that's a quadratic. Two things that multiply to make negative 6 and add to negative 1. Well, I think that would work if we go negative 3 and 2. So this becomes x minus 3 and x plus 2. There's nothing other than 1 to divide by, so we don't have to do that divide by a there. And we'll put the x right there, bring that piece down. And we've now factored it completely. All right, so we try another one here. Let's take out a monomial first. Looks like 4 comes out. And in terms of x, looks like an x can come out. And 4 times x, well, we didn't need an x squared because 4x times x squared is 4x cubed. 4x times what is negative 36x? That would be negative 9. Okay, and then we've got to look at it in the parentheses. Can we factor that? Well, this is a specific pattern here. This is called the difference of two squares. Okay, difference meaning we subtract two perfect squares. So x squared is a perfect square and 9 is a perfect square. And we're subtracting. It only works with difference, doesn't work with addition. So remember, if you recall that pattern, that is x plus, so the square root of this, x, the square root of this. So x plus 3, and square root of this, and square root of the 9, x minus 3. And then we'll bring the 4x down. There we got it. Factored it. So it should be a review so far. Okay. Still pulling out a monomial first here. What comes out of each of those? Well, looks like 10 will come out of the numbers and x out of the variables. 10x times what is 10x cubed? That would be x squared. 10x times what is 80x squared? That would be 8x. And then 10x times what is 160x? 160x, that'd be 16. And I've got to look at factoring it. Now I see a pattern right away. This is when I have a perfect square in front, a perfect square in back. Really what I should try to do is take the root of each of those and see if I multiply the roots together and double them, do I get the middle? And in this case, yeah, 4 times x is 4x, doubled is 8x. So that means I can just write that twice. Now, if you're like, man, I didn't remember that pattern, well, you could just do the same factoring thing that we were doing. Two things that multiply to make x 16 and add to 8. That would be 4 and 4. And you would end up with this as well. Okay? The other way to write this is 10x times, since x plus 4 is the same, we could just say x plus 4 quantity squared. This is called this right here is called a perfect square trinomial. Okay, and this little guy right here is called a binomial squared. Okay, so some things we've talked about in the past there. All right. The next thing you have to do in factoring is be able to recognize the sum and difference of two cubes. So here's the pattern. If I have a perfect cube added to another perfect cube, we can factor that in this format. We'd find out what the cubed root of a cubed is, so we get a. Cubed root of here would be b. And then we'd take a and square it, b and square it, and in the middle we'd multiply a by b and have a negative. And with the difference, a minus b first, and then a squared plus ab plus b squared. Now note the weird thing here. A minus has a negative in front, which makes sense, but then it's all positives in back. Whereas the plus has a positive in front, which makes sense, but then inside here you have a minus and plus. Okay, you have to explore a bunch of patterns to see why that happens. But what I'm going to do is I'm going to just go ahead and look at this. Recognize, well, this is a perfect cube. If you're not familiar with your perfect cube, sometimes it just helps to write them down. We have 1 times 1 times 1, 2 times 2 times 2, which is 8, 3 times 3 times 3, 27, 4 times 4 times 4, 64, 5 times 5 times 5 is 125, and so on. So those are your perfect cubes. Okay? We can keep going, but we'll stop there. So cubed root, yep. So this is x. Cubed root, yep, we can cube that. This is a perfect cube, perfect cube. So the cubed root of this is 3, because 3 times 3 times 3. Okay? That gives us our 27. So we're dealing with the difference here. So we're going to go x minus 3. That's our a, b. So if we think of that as a and b, and you can even write it out on the side, a equals x, b equals negative or equals 3. Okay, and then we would a squared, well, that's x squared, plus a times b, well, that's 3x, plus b squared, well, that's 9. You have now factored it. And you should really, when you're done factoring it, you should see if you can factor the back. And you can't, but you always double check it. There you go. Just a good habit to get into. All right. Now, you also have to still look for greatest common factor. So when I look at this, I go, whoa, hold on, 5s and 0s. Well, 5 goes into that. 5 goes into 135. Boy, that goes in, well, if you're not familiar with it, you could see how many times 10 goes into it, and then double that. But so if you struggle with that, that's okay. But 10 goes into it 13.5 times, doubled is 27. So we would have 5 times 27. Okay, gives me 135. And 5 times, well, 64 gives me 320. And then I could take out, looks like an x squared, the smaller number of x's. X squared times what is x to the 5th? Well, I need 3 more, so x cubed. X squared times what is x squared? Well, no x squareds. We don't need any more. And then I've got to look at this. Well, I recognize 27 as a perfect cube, and x cubed is a perfect cube. 64 is also a perfect cube. Okay? So if you're thinking of your table up here, this would be x. This would be 1, 2, 3, 4, and 5. So the perfect cube, 4 cubed, is 64. So in this case, if we're thinking a and b, a is, well, cubed root of 27. That's 3. X. B is cubed root of 64, which is 4. Okay? So I'm looking at my pattern. I bring down my 5x squared. It's the sum. So I have a plus b, 3x plus 4, and a squared or when I square 3x, that's 3 squared and x squared, so 9x squared, minus a times b, 4 times 3 is 12, x, plus b squared. There we got it. All right. So sum and difference of perfect cubes there. Okay, well the next piece is factor by grouping. And factor by grouping works like this. Look, I've got 4 terms, okay? And when I have 4 terms, I need to go kind of through another process. So let's kind of first summarize what we have here. And this might be a nice table if you write down. First thing you always do in factoring. Factor out A, G, C, F, the greatest common factor. Second thing, count the terms, okay? If there are 2 terms, you're looking for, you're either doing difference of 2 squares, or sum or difference of 2 cubes. Okay? If there are 3 terms, you're doing, well, we'll just call it general factoring. So if you're like, what's general factoring mean? Well, general factoring would just mean that little x thing, if you want to put that as a reminder. Okay, so general factoring is supposed to be an in there. Okay, there you can also do what we're going to call quadratic form. Okay, and I'm not talking about quadratic formula. I'm talking about quadratic form, and we're going to see that here in a minute. But I'm going to add it now just because I know it's coming up. And then if 4 terms, you're looking for factor by grouping. And I'm going to cover all these here. Okay. So, factor by grouping, 1, 2, 3, 4 terms. Always look for a greatest common factor. There isn't one. Grouping, in math we group using parentheses. Okay? Think of it that way. Factor by grouping, we got parentheses. So what you're going to do is just make 2 groups of 2. Now you can pick any 2 terms to go together, and I always start with the first 2 until you get to see these, and eventually you can see which ones need to go together a little better, but right now I'm just going to rewrite this using the first 2 terms in a group, meaning I'm putting parentheses around them. Then I'm going to add it to the second 2 terms in a group, so 4x minus 3 in a group. And then I'm going to take out the greatest common factor of each. I'm going to ignore the back group and look at just 12x cubed minus 9x squared. Is there something that goes into 12 and 9? Well, yeah, 3. Something that goes into x cubed and x squared? Yep, x squared. Okay. Well, when I take 3 times what is 12? That's 4. X squared times what is x cubed? That's x. 3 times what is negative 9? That's negative 3. X squared times what is x squared? Don't need any more x's. And then I look here, well, there's nothing that comes out of there. So just keep that. But what you're trying to do with factored by grouping is get the same sets of parentheses, which we've done here. You have 1, 4x minus 3 here, and you have 3x squared, 4x minus 3. Okay, so there's actually like a 1 hidden right in front there. And we just don't show it because when we multiply by 1, we never show that. But the important thing is that this and this are the same. Those 2 things are our greatest common factor. Remember, we always try to take out a greatest common factor first. So, like when we had, like, say, let's just let's just go back to a previous problem. So, like right here, where we took out an x first, the greatest common factor was x. Here, the greatest common factor was 4x. We took that out. Okay? Here, the greatest common factor was 10x. Well, right now when I look at this, the greatest common factor is 4x minus 3. That's what they both have in common. They're both being multiplied by 4x minus 3. When I take that out, I'm left with 3x squared and plus 1. Okay, and we put it in parentheses because we're multiplying the two things. Remember, back here, when we took out a greatest common factor, the remaining thing was put in parentheses. We took out an x out of each of these. We were left with an x squared, an x, and a 6. We took out a 4x squared, or 4x from each of these. We were left with an x squared and a 9. Okay, so when we're taking a 4x minus 3 out of both of this term and this term, we're left with 3x squared and 1. You have now factored by grouping. 4x minus 3 times 3x plus 1. All right, so let's try another one here. Let's set up our groups. 2x cubed plus 5x squared plus, now I know that says minus, but we're going to put the negative 8x in and negative 20. We're going to always put plus in between the groups. Even if it says minus here, we're putting it a plus there. Okay? And you should always look for greatest common factor, which I didn't point out here. There isn't one here, but you should always look for it. So 2 and 5, nothing goes into it. X cubed and x squared and x squared. So that leaves us with a 2x plus 5. And negative 8 and negative 20. Well, we could take out a negative 4. And x and, nope, so just negative 4. So that gives me negative 2x, or excuse me, negative 8 divided by negative 4 is positive 2x. And negative 4 comes out at negative 20. So negative 4 times what is negative 20? That would be 5. So negative 4 times what is negative 8? 2. Okay. Now notice, whenever you have a negative in here with your front term, you take the negative out, and that's what we did here. Okay? So notice, you always want to get the same parenthesis set. So these things are the same. That is your greatest common factor. So 2x plus 5 is the greatest common factor. Remaining, x squared minus 4. Now, hopefully you recognize, whoa, x squared minus 4, that's difference of two squares. That means I've got to change this piece to x plus 2 and x minus 2, the difference of two squares. And then this 2x plus 5 comes down. You have now factored it completely. All right. Okay, we're now going to go to form factoring. Okay, factoring polynomials in quadratic form. And this is what, look, I've got 3 terms. Always look for a greatest common factor. Nothing comes out of each of these. But what I can do now is I really want to always set things up in quadratic form. In other words, I want, oops, did not mean to switch pages there. So let's go back. Get that switch, okay. I didn't want to do that either. Let's get rid of that. So I always want to get things in the form of something squared plus something to the first power plus my constant, my number, my C term. Okay? So really when I look at this, x to the 4th, I want to get it to a squared plus 6 times x or something to the first power plus my 5. So looking at that, x to the 4th, what can I square to get x to the 4th? Well, I could square x squared. So let me switch up colors here. You can say, well, I'd have to square x squared. Well, what could I raise to the first power to get x squared? Well, x squared. So me looking at this personally, I look at these two things and I go, hey, is this one twice that one? Yes, this power is twice that power. That means I can break this power in half and put it inside and square it. Because 2 squared is 4. 2 to the first power is 2. So that's really what I'm doing there. So I'm gonna do that for each of these just really quick, just so you can kind of see that piece of it. Okay? So when I look at this, first 2, 13, 6, nothing I can take out in terms of numbers. But in terms of variables, I can take out at x to the second power. So that gives me 2x well, times x, well, okay, I need the fourth because x squared times 2x to the fourth is there, plus, and 13x squared plus 6. Okay, so I took out a greatest common factor. And then I'm going to now look at this piece, and I'm going to write it in this format up here. So that'd be 2 times something squared plus 13 times something to the first plus 6. All right, I'm just going to kind of keep this in a box for a minute. Okay, and so remember what I said just a second ago. We're looking at that power and that power. This is twice that one. So when I'm doing this, I could actually say, well, this is going to be x squared and x squared to the first. Okay, and good. I'll go ahead and put that in parentheses, and I'll bring this x squared back down here. Okay, I'm not done with these. I'm just kind of walking through each part. Here, can't take out a greatest common factor. Notice this, though, is twice that. So when I write it in format where I have something squared plus 2 times something to the first plus my 1, well, that something squared would be this number, x to the 7th. So it's just really whatever you have in that second position, x to the 7th is going to go right here. And this is going to be x to the 7th as well. This may seem like a waste of time in the middle, but I'll show you why we're doing that here in a minute. Okay? And so the same thing on this next one. Let's go ahead and look at it, and we can, well, we can't take anything out, but I can look at it and go, well, I'm going to go 81, and that is going to be something squared. I just don't have a first power here, minus 16. Well, something squared, we're going to call, well, that could be x squared, okay? There's another way to do this one as well, but we're going to keep with that, okay? So, with that, and you know what, let's kind of keep the color scheme going here. All right, x squared. So what I'm going to do is some substitution here. I am going to say x squared is equal to u. Okay, that's going to work for all of these except for this one, because notice this says x to the 7th. So this is going to be kind of its separate beast here in a second. Okay, but x squared is equal to u. So I'm just going to rewrite these problems with, rather than x squared, I'm going to put u. So I would now have u squared plus 6u plus 5. Okay, this would be u, right? X squared is u, times 2 times u squared plus 13u to the first plus 6. So notice x squared just became u, and we keep the squared there. X squared just became u. We'll keep the to the first power, just means, you know, x squared just became u. Okay? We're going to skip this one for a minute. We're going to go x squared is going to become u. Okay? And then we have squared, which I'm not going to put the parentheses around for now, 81 minus 16. Okay, and what that allows us to do is look at it easy and factor it. I mean, this is really easy to factor. This just becomes u plus 5 times u plus 1. This becomes, well, u times, well, 2 times 6 is 12, 13. Two things that multiply to make 12, add to 13, 12 and 1. U plus 12 and u plus 1. Don't forget to divide by your a term too. Right, so I'm just doing my normal general factoring, so that is u plus 6 and 2u plus 1. So I factored it. Here, we're going to skip, come back to it. Here, this is, well, this is difference of two. This is a perfect square, and this is a perfect square. So I have 9u minus 4, and 9u plus 4. Okay? So, oh, and by the way, now that I've got that, yeah, that actually looks pretty good. Okay, so now I'm going to just go back, and u is x squared. So I'm going to replace my u's with my x squareds now. So wherever I see a u, I'm going to put an x squared. So rather than having u plus 5 and u plus 1, I'm going to have x squared plus 5 and x squared plus 1. That is my answer. I can't factor either of these. I'm done. Rather than having a u plus 6 and a u out here, this u is going to be x squared. This u is going to be x squared plus 6. 2 times x squared plus 1. So all the u's become x squareds again. The whole point of putting u in there is just to make it easy to factor it. Okay? Here, rather than having u, I'm going to have 9x squared minus 4. Okay, u becomes x squared. And 9x squared plus 4. Now, maybe some of you recognize, whoa, that's, when I put an x squared in here, I have a perfect square and a perfect square again and a difference, which I have to factor again. That square root of 3x squared, or 9x squared, is 3x. Square root of 4 is 2. 3x plus 2, 3x minus 2. So I've got a difference of 2 squares when I put that x squared back in. And here, the sum doesn't matter with the perfect square, so we'll just leave it like that. All right. So that's pretty cool. It's a nice way to factor. The piece here where we have x to the 7th, you can make u equal anything here. We can say, well, u is going to equal x to the 7th. So we can now say, okay, rather than having x to the 7th quantity square, we have u times, or u, excuse me, squared plus 2 times u plus 1. Well, two things that multiply to make 1 and add 2, well, that's just u plus 1 and u plus 1. Or you could write it as u plus 1 squared. And now replace the u with x to the 7th. I have x to the 7th plus 1 squared. Very nice way to do that. All right. Hopefully that makes sense. Okay, last thing, using the factor theorem. Factor theorem just says this. Hey, determine whether x minus 3 is a factor of this whole thing. If it is a factor it completely. So we're getting in the process of trying to actually solve polynomial functions. Okay, so the first thing I'm going to do is I'm going to see if 3 is a factor of this. Okay, and the way I'm going to do that is use the remainder theorem. You can do it two different ways. One way is to just do synthetic division using the remainder theorem. So x minus 3 equals 0. That means x would have to equal 3. So I put the 3 here. I take my pieces, x to the 6th, 2x to the 4th. So all my coefficients. And I would have to remember I have a plus 0x to the 5th up here. And I have a plus 0x to the 3rd. I've got to have those place value holders, and I have a plus a 0x. So all these terms that I'm missing in terms of powers here. So I'd have a 1x to the 6th plus a 0x to the 5th plus a 2x to the 4th plus a 0x to the 3rd minus a 16x squared plus a 0x minus a 32. Okay, and if this is a factor of f of x, if 3 is a factor of f of x, then my remainder will be 0. So I go through, that's 3, 3 times 3 is 9, 2 plus 9 is 11, 3 times 11 is 33, that's 33, 3 times 33 is 99, that is 83, 3 times 83 is 200, it's 249. Okay, and that gives me 249, and then 3 times 249 is 747. Which gives me a remainder of 715. This is not a factor. So we don't have to go any further. Not a factor. Okay. Now the other way you could have figured that out is, it's kind of messy, but you could have done f of 3 and then just substituted 3 in for all the x's. Oops. Okay, which in that case you get like 729 plus 162 minus 144 minus 32. So I've calculated those out earlier. And that would still give you 715. So f of 3 is 715, which does tell you one thing. I mean, like if you were looking at this graph, when your graph, whatever your picture looks like, okay, this point right here would be at y equals 715. That's what that tells you. Okay, so let me make just kind of a easier curl so I can label this. Okay, that would be 715. This would be 3. That's a point on your graph, but it's not an intercept. It's not a solution. It doesn't cross the x-axis there. Okay, it's not a 0. So, by the way, that's definitely probably not what that graph looks like. Okay, definitely probably not. I know that doesn't make much sense, but so let's look at a different one here. Let's say determine whether x plus 1 is a factor. Okay, so that would mean I'd have to test x plus 1 equals 0. I'd have to test negative 1 because x would equal negative 1. So I'm going to put negative 1. I'm going to let my coefficients 4, and there's an x squared, so negative 1, x squared minus 4x, and plus 1. And we'll go ahead. That gives me 4. Negative 1 times 4 is negative 4. Negative 1 plus negative 4 is negative 5. Negative 1 times negative 5 is 5. Negative 4 plus 5 is 1, and negative 1 times 1 is negative 1, and 1 plus negative 1 is 0. Hey, all right, a remainder of 0. That means it is a factor. That means x plus 1, right here, is a factor of this. X plus 1 goes into f of x this many times. That many times represents 4x squared. Remember, it's always 1 less than that power, minus 5x plus 1. Which means we've now factored it. Okay? So we went from, just so we're clear what we've done here, we've actually went from f of x equals 4x cubed minus x squared minus 4x plus 1 to f of x equals x plus 1 times 4x squared minus 5x plus 1. And we could actually try to factor this quadratic now. That should be our next step, is to factor this. Okay, and I keep trying to circle it without blocking my numbers, but there we go. So really that means I want to find two things that multiply to make 4 times 1 or 4 and add to negative 5. It's looking promising because it looks like negative 4 times negative 1 would do that. Negative 4 times negative 1 is 4. Negative 4 plus negative 1 is negative 5. So I could say, well, that becomes x minus 4 and x minus 1. Then I got to remember to divide by a, divide by that 4 and reduce. So I get x minus 1 and 4x minus 1. Since I can't reduce or anything, I just bring it out there. And don't forget to bring this piece down. So that means you factored another piece. So now we know f of x equals x plus 1 times x minus 1 and 4x minus 1. Which means the whole point of doing all this right now is so that you can solve. If I said, well, I really want to know where my graph crosses the x-axis, however, this thing it definitely does not look like that. Okay, let's make it look a little more realistic. Okay, so maybe something like this. All right. I want to know where it crosses the x-axis at. Well, I would just say that's when f of x equals 0. So this point is something 0. This point is something 0. This point is something 0. What are those? Well, it's when f of x equals 0. Okay, So we could use the zero product property. Well, what makes this 0? -1. What makes this 0? +1. What makes this 0? Well, add 1, divide by 4, 1/4. So that means x would equal -1, 1, and 1/4. -1, 1, and 1/4. Probably in a different order there. Oh, I did not want to lose my x-axis. 1/4 would go there. The 1 would go there. That's what we've got. We've now just solved a polynomial function. Now that, all it did was tell us to factor it completely. So technically, the answer they want is this. We just took it a step further. All right. Well, that's all I got for you. Good lucky.